Hello everyone, welcome to this video. So today we will be discussing the second question of RMO 2023. So it's again a geometry question. Uh, so I have the diagram here. Let's start. So we are given let omega be a semicircle with AB as the diameter and CD is a variable coordinate such that the length of CD is constant and C and D lie on the interior of AB. So as you can see here, CD is given, right? Uh, we have to prove, and E is also a point such that the angle which CE makes with this line, with the line AB, and the angle that ED makes with the line AB are equal, right? So as you can see, the blue angles are equal, right? And we need to prove two things. We need to first prove that the measure of angle CED is a constant, right? So and the second thing is that we need to prove that circumcircle of CED passes through a fixed point. So this question is actually not very tough, and I mean simple angle chasing and a bit of common sense can you know use to solve this question. Uh, the main thing here is to focus on the point E. So as you see here, we are given that CD is constant, right? So it means that um, angle DOC, so this angle, the green angle right there, so that angle is a constant. So what we will prove is that E is actually the intersection of some circumcircle of COD with the diameter, and as you can see, as we are varying that point C, C and D are as they are varying, as the variable chord is varying, the circumcircle is always at O, like the circumcircle always passes through O. Circumcircle of CED passes through O. And the proof is as follows. So we assume a point E dash. So I'm just renaming this as E dash, such that E dash is the intersection of the circumcircle of COD with the diameter, right? Uh, and like if you do very simple angle chasing, you notice that DE dash C is equal to DOC. So these green angles are equal because angle in same segment in cyclic quadrilateral is equal because CDOE dash is cyclic quadrilateral, right? As you can see, because E dash is defined like that. Also, um, uh, as you can see, since OD and OC are equal, so those two lengths are equal. These two lengths are equal because the radius. It means that these two angles are equal because it's an isosceles triangle. है ना? And uh, if you again look at the segment OD, then the angle at C should be equal to the angle at E for the cyclic quadrilateral, right? So this blue angle equals this blue angle, and similarly this blue angle which is equal to the angle at C. So this is the interior opposite angle, and that is equal to the exterior angle of the cyclic quadrilateral. So these two angles are equal, and basically all angles of the same color are equal. So it means that CE angle and CE dash angle and DE dash angle are equal. So E dash is basically satisfying all the properties that E is supposed to satisfy. E dash lies on AB, and the angle it makes with CE dash and DE dash with the same angle with respect to AB, right? So it satisfies both the properties, and that is why we also have that E dash is basically E. So it means that E dash is equal to E. And I mean you can use them, you can just call COD as 2 theta, then this will become 90 minus theta, and this will also become 90 minus theta, right? Because the sum of angle has to be 180 degree in the triangle, and this will become 2 theta. The green angle is basically 2 theta and the blue angle is 90 minus theta. So as you can see, that is being proved here. And so using this one chunk of proof, like one paragraph of proof, we have proved the entire problem. We have also proven the measure of C E dash D is constant, because as we know E dash equals E, and the angle CED equals angle COD, and angle COD is a constant, right? Because CD length is constant. So that we have proved that, and we have also proved that CED passes through a fixed point, which is the center of the circle, right? So this proves, like it proves two things simultaneously, and as we call in Hindi, एक तीर से दो निशाने. So uh, the problem is done like this. But I also find another method which is kind of similar, but it's more. I mean, I found it more better. So let's check that out as well. So I'll just explain that method. Let's see. Okay. So here I'm defining points C naught and D naught to be the points such that they are symmetric about the perpendicular bisector of AB. So this is the perpendicular bisector of AB, and the chord C naught D naught is symmetric about this perpendicular bisector. And basically this line C naught D naught is parallel to AB, and what I'm doing is I'm completing the semicircle to form a big circle. Okay, so that's one thing. One more thing is that, as you know, we have been given that angle CED is supposed to remain constant, and we are also given that angle CEA should equal angle DEB, right? And if you back think the question, like if you kind of think that what angle CED and what the other angles should be, then you will notice that angle CED initially, for like if you take C naught and D naught, it's this 2 theta angle that we had, right? So it is a 2 theta angle. So angle CED is also a 2 theta angle, which means that angle CEA and angle BED, so those angles are 90 minus theta and 90 minus theta respectively, right? So this angle and this angle, I'll just mark them. Yeah, so that angle, and as you can see, like it's coming 52.38 degree, like that value, but that is the angle. I'll just remove the label so that it's more clear. Okay, so those angles should be equal. Now this is also equal to these angles, right? Because these angles are also 90 minus theta and 90 minus theta. So this basically means that ED is parallel to OD naught and EC is parallel to OC naught, right? So now we again use a bit of back proof, like reverse proof again, and I'll just remove the angle. So we prove that if we take any random point on the diameter AB, and we make these lines parallel to OD naught and OC naught through E, which intersect the circle at C and D, then the length of the arc CD is a constant. So we prove it a bit reverse manner, right? Basically what we are doing is we are assuming the final uh, like the final result, and we are going back to the original thing, and that will basically prove it. Okay. uh, so I mean, you can just think of it like a converse proof. Like if angle CED remains constant and C and D are equally inclined as well, then CD remains constant. So it's that is what we are proving. uh, and you will see how that also proves the original question. So the thing is that, uh, let CE be extended to meet the circle at some point D dash. I'm calling it D dash for a reason that we'll see later. As you can see here, these two lines make the same angle. Like if you extend C naught beyond O to a point some D naught dash, okay, then these two lines, so this line and this line make the same angle from the diameter, which means that this segment OD not dash. So this radius segment right there, and this segment, so basically the reflection of each other, which means that D naught dash is a reflection of each other under line AB. So like, as you can see, and similarly, uh, since these two lines are, this line is parallel to this line and this line is parallel to this line, it basically means that these two angles are same as well. And since these two angles are same, it means that D, and since it's a circle, it's a diameter, it means that D is a reflection of D dash under segment AB. And these results are very powerful because, as you can see here, these two lines are basically parallel to each other, and we know that if two parallel lines cut a circle, then the corresponding chords, I mean the corresponding arcs, small arcs that you get are equal. So I have marked those arcs in green, as you can see. And a very easy way to prove this is to just show that this figure that is formed here, the quadrilateral, this quadrilateral is an isosceles trapezium. And how you can prove it is like this. So you take the segment D dash C naught. So basically you join the diagonals, and as you can see, this this small angle made by the diagonal with the side is, let me just mark those angles. So I mean it's a very small angle, but as you can see, 7.34 degree right there. And D naught, sorry, D dash, I just you know so basically D dash C naught, uh, D naught dash, so that angle right there is also 7.34 degrees, and that basically is true. And as you know that C D dash and C naught D naught dash are parallel, so angle C naught D naught dash C is also 7.34 degree, which is like that same angle. And that basically means that C naught and D dash D naught dash extend the same angles on the circumference, so hence the arcs are equal, right? Okay, that's one thing. And the second thing is that since D is a reflection of D naught under the diameter, and D naught dash is a reflection of D naught under the diameter, sorry, D dash is a reflection of D, so D dash, as you can see, D dash here is a reflection of D, and D naught is a reflection of D naught dash. So angle D naught, I mean arc D naught, so this green arc right there is equal to arc D naught dash D dash, right? So these two green arcs are equal, and these two green arcs are equal as well. So angle arc D naught equals arc C naught, which means that the arc has shifted by equal lengths, I mean equal angles, in C and D direction both, right, in the same direction. So it's like, even this has shifted anti-clockwise and even this has shifted anti-clockwise, and that basically means that CD arc length remains constant because this green arc is added and subtracted, right? So that basically means that that length of that arc CD is constant, the length of CD is constant, and so is the angle COD. Okay, and we proved this thing by assuming before that angle CED is also a constant, and that constant equals the angle 2 theta which we had, right? So it means that angle CED equals angle COD because both of them are 2 theta, because the measure of arc CD is equal to the measure of arc C naught D naught, which is 2 theta. So the points C, E, O, D are actually cyclic. right? And this basically means that the and this proves the B part of the question, that the circumcircle of uh, CED triangle passes through a fixed point, which is the center, right? So that basically proves the question. I hope you enjoyed both the methods. Please like, share, and subscribe. Please like and share the video. Subscribe to my channel, and share this video. Forward it to all your friends who are interested in math and geometry and maths Olympiad and RMO and all of those things. Uh, Thank you for watching, and we'll see you in the next video.